Hello, in this video we will see good SQL declarative programming versus wrong imperative programming. All these examples will be atomic, so no transaction will be split in multiple transactions because the situation will complicate too much, and you can guess when you have multiple transactions you can have a lot of errors. And also because doing things in an atomic manner doesn't spare you from doing big mistakes. So I will start with an example which is good declarative programming, and I will expand it to bad declarative programming. Bad declarative programming because it uses imperative programming style. Imperative programming style is not good for database, never. And indeed, when you have imperative programming style, so you have a UI, a user interface, a graphical user interface, is almost impossible not to mix rules of imperative programming with database programming ones. Fortunately, none of the imperative developers are aware of these things, and only a few of database developers really understand things at this basic level, which I'm going to demonstrate today. The demonstration will be done for Postgres, but the same thing happens for every relational database engine. Think of Oracle, think of a SQL Server, maybe MySQL2, DB2 for sure, and so on and so forth. So don't look at the fact that we do have Postgres. This happens every time. And don't disregard the fact that the demo today uses only atomic actions in one single transaction. Yes, concurrent transactions. So let's see the version of Postgres, which is 17.5. As usually, we are using the most recent available versions. Let's reset our environment. And the environment is an environment composed of 3 people in one table. Each of them has an account balance in its account, and we will move some values from one account to another. So we will expect for this grand total to be always the same. The good example, and let's start with it, is this one. We update both accounts in the same transaction, and we update these accounts doing a single operation in a single statement. Even if we do have 3 phases, I mean the fetch phase, we get the value from the table, we modify it by adding or subtracting the transfer amount depending if we are at source or destination ID, and then we put the modified value back. We do all these things in a single SQL statement, and this is crucial, as you will see with the other 2 examples, which are definitely wrong. Here, yeah, we do have check for us to know that the amount was indeed moved, not lost, because we need to have either no update at all or 2 updates. Sure, it couldn't happen 2 updates for the same user because the IDs are a primary key. But this is not so important. So let's see how this is working. Everywhere I have added PG sleep, just in order for me to be able to move from one tab to another and start the second transaction. I'm not that fast, so we must accept this. Okay, let's do the good example first. We will move 50 from ID1 to ID2. And then we will move 75 back from ID2 to ID1. As a matter of fact, only 25 will be as a result. Okay, let's see what happened after the first transaction. Indeed, the 50 was retrieved from Alice and John is richer by 50 now. Okay, let's do a commit here in order to see what happened in the second transaction. Here we put 75 back, so we expect this result. 125 and 175, because it was 150 minus 200 was, no, 100 was, minus 50 plus 75. And we have the same grand total as you have expected. Okay, that's the good example. Everything in a single SQL statement. Let's reset our environment, because right now the environment is affected by the modifications we have done. Okay, let's reset. As you can see, we are starting from scratch with the same existing values. Let's execute the second example. What I did in the second example, I split the update into two updates, one for ID source and one for destination. Again, we have the same fetch, the same modify, the same write back in a single statement, but this time we have one statement per ID. For each ID, we have its own statement. And this will lead into a deadlock situation, or may lead into a deadlock situation. It is not sure that you will always have a deadlock situation. And again, this happens for every database engine in this world. SQL database engine, I mean the ones that do not because we have deadlocks. Let's start it. We move 50, we move 75 back, and what we have here? Yes, we have it. We moved it, and now the second transaction entered into a deadlock situation and was rejected. This one was rejected. Let's see. Was it indeed rejected? We remember the result here. Let's do a commit. Okay. Let's test here what we have. Yes, it was rejected because the 75 part didn't actually happen. So the grand total is the same, but with the penalty of having an error, and the transaction, one transaction was rolled back. Okay. And now we will see the worst part of it. For example, imperative developers might want to use a debugger, and for debugger, they would love to see the values that were retrieved from the database and then modified. What we have here? we have decoupled the fetch into its own statement. We have kept the modify and the write back into its own statement. But this is not enough. And this is very wrong. Decoupling fetch from write back leads to concurrency violations and to bad data. And this happens, for example, when you get the data from database, put it into a user graphical interface, modify it there, and come back and write the modified data, but not the difference, the modified data. So this is a basic example of how not to do things. Okay, let's see. Yeah, we have to reset it. We did the reset. You can see now we have 100, 200, 300, and the grand total of 600. Let's execute the last example. Let's quickly go to the second and execute the last example and wait for the transactions to finish. Okay, this one finished. Now we have 50, 250, 300 as we knew it should happen, and the grand total as we expect it to be. That's fine until now. But let's see here. Here we have a different grand total. So some money were lost. Some money were lost. Why is that? This is because the very moment when we have did the fetch, this very moment the data we fetched can be aged, can be too old to be used next. So as you can see here, decoupling the fetch from write back was a wrong decision and led to some garbage data. And this is the worst case scenario you can happen in your daily life. How to solve it? I will let you do whatever you think, but the best is to do all the things in a single SQL statement. Atomicity doesn't help you and doesn't save you. And that was all for this video. Thank you for watching.